Hello, my name is Muhammad Shahrul Mizan bin Muhammad AZMAN, and my student ID is 2019416244. My final year project title is Design and Finite Element Analysis of Locking Compression Plate for TIBIA Fracture Treatment. This project, the bone fracture is the most common orthopedics problem. Osteosynthesis surgery is used for internal fixation of bone fragments. In order to achieve stability of fixation, compression plates are the solution to regain and heal through biological internal fixation. Locking compression plate, also known as LCP, is widely used in medical field for internal fixation. The challenges encountered during LCP is the stress shielding occurs during bone remodeling. The plane is restricted to certain displacement during bone remodeling, which restricting the bone's growth. A versatile plate is needed to minimize or eliminate the stress shielding. A product design must be developed. Stress and displacement of the design will be analyzed using linear finite element analysis. Using CATIA, experimental of new material will be conducted to obtain the mechanical properties, which will be applied in the FEA simulation for other materials. Results from both experimental and theoretical will be compared. Locking compression plate will then be fabricated. So the introduction is the tibial shaft fractures are the most difficult injuries to treat due to the complication and major disabilities. People who suffer with bone fracture is due to traumatic injuries, which is falling from height and car accidents. In some cases, bone fracture did not heal normally. It is due to the secondary healing. The healing was stunted by the intramembranous and the endochondral. Fracture management have been involved mechanically with the idea of minimally invasive plate osteosynthesis, which is MIPO, used with the locking compression plate. Locking compression plate has some advantage in fracture fixation, combining angular stability with locking screws with traditional fixation techniques. It is widely accepted by orthopedists. Patients made uneventful recovery after he sustained injury and plate bending was manipulated under anesthesia for the same. Many researchers have explored ways to enhance the locking compression plate, including design and material supply. Some designs have different. This can be seen where certain plates comprises different shapes and holes. Some plates are flat, some plates have curvatures. Absolute stability is required to achieve primary healing. Current material used is the titanium alloy, stainless steel, copper chromium, which have high stiffness materials and also the dominant cause of stress shielding. Literature review on bone anatomy. In human skeleton, we have 206 bones, consists of 80 axial bones and 126 appendicular bones. The function is to support structural body, to protect internal organs for movement such as legs and arms, the storage of phosphorus and calcium, and transportation, which we can see as such as red blood. We can transport nutrition into the body. And the tissue bone, we have tissue bone comprises into three, which is compact tissue, cancellous tissue, subchondral tissue. Tibia is a distal part of the limbs and is the joint of the knee with the femur bone, and is the second largest leg bone after the femur, and it is prone to accidents, especially in car accidents. Bone fracture is associated by injury or high force. Fracture configuration of the bone fracture is transverse, oblique, spiral, comminuted, and segmental. Open fractures encounter after high energy motor vehicle, or we call high force of accidents. Locking compression plate is small and flexible metal implant, consists a plate and screws. The advantage is the stability of fixation is achieved by compressing the plate to the bone. Compression brings two pieces together in order to fix fixature, and so that they can resist one another. It is common for transverse and oblique fractures. So the problem statement occurs for this project is bone fracture is critical healthcare problem, especially in USA. The common fixation for internal fixation is using locking compression plate, and with that, stress obtained in the plate, therefore it will affect the bone density and affects the stress shielding. Implants will be loosened and bone loss phenomena will happen. Therefore, the objective of this project is to design the best locking compression plate, to compare the results and effects between finite element analysis and experimental, and to fabricate locking compression plate. What is the scope and limitation for this project? We benchmark the product, and we will use the benchmark and we will improvise it with other specification from other designs. And we will focus of fracture on the tibia of the shaft, or we will call it the shin. And we will experiment a new material. Experimental of the results of experimental will be then used for the simulation in the finite element analysis on other materials. Therefore, the results of the simulation will be compared with the experimental. The simulation will conduct in is linear simulation. So the methodology, we have the problem statement, and we review from the literature, review from journal and articles about the problem statement, and we design the locking compression plate. After we design it, we will analyze the locking compression plate using the materials from previous research and also the new material. Therefore, from there, we can compare the results from the experimental and the theoretical, which is from this simulation. So what is the expected results? So the expected results is the concept design is to be generated based on improvisation, where we use a benchmark and we improvise, and we also use other designs to improvise our design. Therefore, to determine the number of screws also, we review from the literature where 3 or 4 screws on each side of the fracture is sufficient. We want a drawing of the design generated, and we want to obtain the mechanical properties on the new material through experimental. The values of the experimental of the new material will be used for the simulation of other materials. Then the results of the simulation will be compared. So this is the expected results table, where we have cortical bone, stainless steel, glass fiber, and bamboo, and the new material. And the right is the design that we came out. So that's all. Thank you.